Good evening, everyone, and welcome to the latest session in the Formula Bharat virtual series brought to you in collaboration with MathWorks. My name is Ashen Rodrigues, and I'm thrilled to have you all join us today. In today's session, we'll be diving into a crucial topic in electric vehicle design and engineering storage solutions, modeling and stimulation of battery systems. This session is especially relevant for anyone passionate about advancing their understanding of electric vehicle technology and battery management systems. We encouraged you to stay tuned, ask questions, and make the most of this opportunity to learn from our industry expert. Our expert speaker for this session is Mr. Veer Alakshendra, Manager of Education Programs at MathWorks. Veer brings with him a wealth of experience and knowledge in leveraging MathWork tools for engineering education and practical applications. Today, he will guide us through the exciting world of battery modeling and stimulation, offering invaluable insights into how these tools can support decision making during the design process. During this session, MathWorks will provide a comprehensive demonstration on developing battery models and battery management systems. You will see how these advanced tools can help optimize your designs, streamline processes, and evaluate various architectures effectively. The presentation will highlight the use of SimSCAP battery, a specialized tool set featuring parameterized models to design state-of-the-art battery systems. We'll also explore Battery Pack Model Builders, a powerful resource for inactively evaluating different battery pack configurations. This session promises to be a game changer for all those interested in electric vehicle systems. So, to get ready to take notes and engage with the content. Throughout the session, feel free to drop your questions in the YouTube live chat. We'll address as many possible during the Q&A segment towards the end. This is your chance to interact directly with the expert and enhance your understanding of battery modeling and stimulation. Without further ado, let's dive into the session. Please join me in welcoming Mr. Veer Alakshendra as he takes us on this insightful journey into the world of battery systems, modeling, and stimulation. Thank you.
Yeah. Thank you, Formula Bharat, for again giving us a chance to go live on the Formula Bharat YouTube channel. So let me first share my screen and I'll quickly just, yes. Okay, I hope my screen is visible. So just a disclaimer, I just figured out that before the session, I figured out that in one of the screens, things are not properly working. So there was some vertical lines. So I have to change my screen and also the camera position. So if I go back and forth, like here from right to left, it is because of the change in the screen. Okay, so I hope my screen is visible. So I'll get started and share. Okay, yeah, perfect. Uh, yeah. So, okay, so my screen is all set. I'm just checking the audio and visuals. Awesome. Okay. So, hi everyone. This is Veer Alakshendra from MathWorks, and I am a part of the education programs team at MathWorks. I'm based out in Bangalore, India, and I've been working with multiple student teams across the world to help them get started with MATLAB and Simulink or different other toolboxes for different automotive competitions. So today we are going to talk about modeling and simulation of battery systems with SimScape battery. Specifically, we'll be talking about what SimScape battery is and what are different blocks that can be readily used for your modeling purpose in the Formula One competitions. So with this, just a short intro, let's get started and try to understand that a scenario where your vehicle, you have one vehicle and you're going or participating in multiple competitions. Now, what can happen? So you can have different kind of challenges. For example, like if you go from Formula Bharat to maybe Formula 2 in Germany or Formula 2 in UK. So the environment is changed. So there are variation in the environment. You can have noisy race environment. So that is one point. You can have, as you uh, drive your car, you can see the decline in accuracy over a long endurance run, or even if you just take the endurance run that you perform at the Formula Bharat. Now, another important aspect that we see is the effect of temperature. If you're going for an endurance run or if you're going for different dynamic events, how the temperature is impacting the vehicle performance, and so on and so forth. There are different kind of scenarios and conditions that can be encountered when you're at the Formula Student competition. Now, if that's the case, how about if you have a digital twin? For example, if you have a model where you have all different components or different kind of systems incorporated in one model, and these are all coupled to each other. For example, you have a vehicle model where you have the vehicle dynamics, where you have your tire model, where you have suspension model. Further, you have a powertrain model where you have the source. For example, battery. You can also measure state of charge, and then health of the battery. Then you have a full different kind of motor. You have motor controller, and as well as you have a control system. For example, vehicle control unit. So if all these are in one model, and focusing on let's kind of the just on the powertrain and further into a battery block or a battery pack, where you can model and parameterize a cell, and you can build a battery pack, and at the same time you can define the pack fidelity. When we say about the pack fidelity, it depends upon how complex you want to keep your battery pack or your system model. For example, you can just have a simple lumped model of a battery pack, or you can have a grouped model of a battery pack, or you can have a detailed model of a battery pack. Then further, you are able to measure the temperature and voltage of each cell. Of course, it depends upon how complex is the model. And then if you want to create a scenario where you're running the vehicle through a track, and you want to impose certain fault, and then you want to test the performance of the vehicle, performance of your battery and the powertrain. And at the same time, your team member is also interested in designing a custom BMS and thermal management systems. And now once that is done, you can use that model and generate code for a respective hardware. Now, if if you get all these, I mean, these are all the things that you have the answer for. Like you can model a parameter cell, battery, you can build a battery pack, and so on and so forth. All these points can be checkmarked. Now, this all the model that I'm showing, it is available on File Exchange at GitHub. When we publish the video on YouTube, we'll also link that model and further models, and also some of the resources that can be used for further study. So today, what we're going to learn, we'll focus on the physical modeling aspect, which is done using Simscape. And further, if you get into the battery part, it's the Simscape battery. Now, what we'll try to do is we'll try to focus on an electrothermal pack model. So there will be certain specifications. Don't get confused. It's just that we wanted to build a story around it. So that's why we'll try to show you what are the steps taken, what are the steps you need to take to build an electrothermal pack model, and further how you can use the built-in, or you can say available blocks which are there in Simscape battery for BMS or kind of making a thermal management systems. Now, going ahead, just quickly, let's focus on like how Simscape or a physical modeling is important for building electrical systems. So we'll come to the definition of Simscape, but slowly we'll eventually go over there. But those who are aware, I'm assuming that those who are watching live, or most of the Formula Student teams with whom I've encountered, they know that what is basic MATLAB and Simulink. So Simulink, what is Simulink? It is a simple block diagram environment where you have available blocks. So if you have equations, you can use those equations to model a system. Now, this is one example where you see one RC circuit over here. So now if you need to model it, so what is the rule? Like you can derive the equation or you can already get the equation on internet or from textbooks, and you can either solve those algebraic differential equations, or you can convert it into a state space model or a transfer function. And then for a certain input, you can measure what is a certain output for that. Okay. Now, another approach is replicating the physical layout into an environment which is already providing you physical blocks. So that is what called physical modeling. Okay, so which can be done using SimScape. Now you can see over here that these are bidirectional flows because these are based on energy transfer. So if you try to connect any sensor on these branches, you'll be able to measure the respective physical signal. Okay, so what is the advantage? So one of the advantages is that if you need to build or kind of a model on top of it, for example, if you want to add one more RC circuit or in this one, something like this. So one approach is from modeling aspect, you can again have the equations and you can build the model using the blocks which are available in Simulink. Alternatively, what you can also do, you can again just replicate the same thing with proper connections, basically replicating the physical layout of your system. So for in this case, what we'll do, we'll just add one more loop to it. Okay. So, sorry, one more circuit to it. So now you can see that it's quite easy also because you don't have to derive equations. These are already in place in the in your SimScape blocks or the physical blocks. Now, this doesn't mean that you need to use them separately. No, you can definitely use them together. For example, there are certain blocks, physical blocks that you see over here in SimScape, you can utilize that. And if you see, for example, some certain blocks which are not there, for example, the best example is like implementing a driver model or implementing a control system model or implementing a torque vectoring model. So that you can model in Simulink, and there are certain ways in which you can convert the Simulink signal to physical signal, which I'll show in one of the examples. So through that, you can build your whole system. So both of these, Simulink and SimScape, these can be uh, uh, built together, and you can simulate the model. Okay. Now, just to give an overview, what SimScape is, I think everyone understood by now that it is a foundation physical modeling blocks in different physical domains. It can be mechanical, it can be electrical, it can be hydraulics. Okay, so you can see we have batteries as well, and you can, if you want to perform any multi-body simulation, that can be also done. And if you want to customize certain blocks based on your requirements, that can be also done using SimScape language. Okay. Now, further, if you focus just on the battery, so we have another product which is called SimScape battery. Okay, which we'll be talking more about this. But those who are new, just we have put a slide over here that if you are new to SimScape, there are on-ramps which we have spoken about in these videos, and we have published a dedicated SimScape essentials for automotive student teams. So currently there are 3 videos. You can have a look into that, and it will help you get started how you can use the physical modeling concept to build vehicle models and simple electric powertrains and also simple motor cooling system. And at the same time, videos are available on YouTube, and also the models are available on GitHub and the File Exchange. So going ahead, getting back to our topic, that SimScape battery. What is SimScape battery? Again, it is built on top of SimScape, where you can design and simulate battery and energy storage systems. So you can have electrothermal cell behavior, you can design a battery pack, and you can also build battery management system or thermal management systems. And then further, like whatever BMS that you design, these are all code generatable, and you can also validate algorithms using HIL testing. So now what we'll do today is, for today's talk, we'll start one by one. We'll start with a cell. We'll further make a pack out of it. And later then we'll implement, we'll see how you can add cooling plates, even though for the Formula Student teams, whether you're using cooling plates or whether you're not using cooling plates. It is just a kind of information sharing that we are doing. It depends upon team decisions and team requirements, and there are a lot of things that you need to take care. Based on that, you can make the decision. Okay, this is just a kind of overview that we are here to provide, starting from a cell to battery pack to implementing cooling system, and further also building how you can utilize battery management system blocks which are there in Simscape battery. Okay, now we'll start with a cell. This is the most important part before you directly jump into getting a battery pack. Okay, now if we have to model a cell, I mean, what we have seen in different automotive competitions, there are different geometries. Either you go with cylindrical shape, or you go with a prismatic cell, or you go with a pouch cell. And based on that, there are different topologies that you want to make. For example, if you want to go with a pouch cell, there can be topology like a single stack. Okay. And then you can have different number of cells in series, different number of cells in parallel. Okay. So all these flexibility to choose different kind of cell geometries are there in Simscape battery. We'll look into that, but just to give an overview that there are different kind of shape of the cells geometries and topologies that you can select. Now, going further, what we'll do is when the screen is being highlighted with certain things, we'll just showing that these are the specifications of cell or battery pack that we are selecting. For example, let's imagine that we are implementing a cylindrical model, and then at the end, by the end of the talk, we'll see that how these are being implemented in a model and how adding different BMS blocks we are getting the expected results. Okay. No, so now again, getting back to our cell. Okay. So now if you consider a cell, a physical model of a cell. Okay. So in that case, how do you model? So one of the, I think the most common approach is having an equivalent cell model, which is comprising of EM, a voltage source, then you have RC pairs and different resistance. Okay. Now, similarly, if you want to model thermal equivalent of it, so what it will be comprising of a mass of the cell and further thermal resistance. Okay. Now, further you can have power loss from the electrical to the thermal part, and then you can also, the temperature will influence the electrical behavior. Now, if you need to create a custom cell, okay, we already have physical blocks, so we'll look into that. But if you want to create a custom cell based on the method that you want to follow, for that you can use the language which is called Simscape language. We are not going into detail of this because currently the battery blocks or the cell blocks that we have in Simscape or Simscape battery, those are enough for the Formula Student competitions or any automotive major competitions that we are seeing. However, if you still feel that your focus in the competition is on customizing a battery, in that case, you can use the Simscape language. Okay. Now, without any delay, what I'll do is I'll open MATLAB and I'll try to build a simple battery model, nothing crazy, a simple battery model. And from there, we'll try to see that, okay, if you want to parameterize it, the model, how you can do it and how you can use different optimization techniques. Okay. So let me just, since I move my screen, I'm just setting few things in my screen. Okay. So yeah, I hope everyone can see MATLAB on my screen. If you don't, just you can put that in the chat and I should get the message in my chat, or the organizer can just let me know if there are anything which is not visible on the YouTube live screen. Okay, perfect. Thanks. So yeah, so those who are new, if you want to just get to the library, what are different blocks, you can just type Simulink. Okay. and this will open the page. And from there, you can, if you just open a blank model, so this is the canvas which we use to model Simulink models. And then you go to library browser, and further over here, you can see that we have Simscape. Okay, and then Simscape, you have batteries, you have driveline. As we were talking about multi-domain systems, so these are the different domains in which you can get the physical blocks. So you have foundation libraries, you go to electrical, you can see electrical elements like a diode, and then you have resistors, then you have transformers, and different blocks are present over here. Okay. So another way is that either you drag and drop from this library to the canvas, or you can simply start like looking for the blocks. Those are there by double clicking on the canvas. Okay. So I'll close this and I'll just use a different command, or ssc underscore new. So what it does is it opens a canvas with some default uh, blocks which will be needed in while you are working in the SimScape modeling. So I'll just remove few things from here. So that's currently not relevant to us. And then I'll double click and I just bring one battery. Okay, so when you go over here, so there are different options. You have battery, you have uh, battery cells, you have battery table based. So depending on your requirement, like you can choose. You can, once you click the select these, you can also go to the document and you can explore more whether it is of my use or not. Okay, so I'll also do one thing is format and then auto name and name on. So this is the battery which is table based. This is what I'm selecting currently. Now, what it does is, so this models a battery. Okay, and which is based on table, basically that if you have some kind of data with you for of a cell based on, for example, the HPPC test data, okay, that can be used over here. You can input the values and then you can get started. Now, what it is asking, if you see over here, it is asking for a lot of values. So don't worry. There's a procedure to get the values. I'll talk more about that. But just to also let you know that because of our development team, they have been kind of adding more and more features to these blocks. So if you go to click to start, so it opens page, which lets you select uh, certain manufactured batteries which are already over here populated with the values that you need. For example, if I just click on Panasonic, this one, and then I apply all, so it will populate with all the values over here in this block. Okay, so again, it depends. Considering that it is a Formula Student competition, I don't know whether you'll be able to find that close to cell over here, but you can explore. Otherwise, there are other ways to kind of populate all these values. So then further, you can also, if you want, if you want to understand the block, you can go to description. Okay. And when you click over here, I'll just bring it on my screen. So you can see that there's a nice documentation, which is showing, okay, what this model talks about. So basically, if you again see, it is basically the same equivalent cell model, okay, that we are using, okay, over here. So all the information is provided over here, that how we are modeling the block. Now, further going back, so let's get back and kind of try to build a simple battery system where the goal is that we want to discharge the battery. So for that, what we'll do is first, we'll get a controlled current source. Okay. And again, just for the sake that you know what are these blocks, I'm putting the name on and I'll make the proper connections. And then since I want to discharge it as per the block's sign convention, I'm just using a constant block over here, and I'll take -1 because I want to discharge. And then if you try to connect these blocks there's a Simlink block, there's a Simscape block. It won't get connected. Why? Because we want to convert the Simlink block. This is this giving you the Simlink signal, whereas this requires a physical signal. So if you want to try to connect, it won't get connected. So we need to just bring a Simlink to PS converter. So you connect these two over here, and then you connect, so it will get connected. Okay, that's one thing. And then you need some kind of ground. So for that, we'll bring electrical reference, so which is natural, I mean, which is but obvious, because when you're working on electrical systems, you need a electrical reference. So we are connecting it. And then there is a solver configuration. So this is a solver for the Simscape modeling. So uh, it is like when you start any Simscape model you look into it, this block will be needed by default. Okay, so I mean, if you want to go into more details, you can have model settings. You can have like what are the solvers in Simulink. You can select that. But if you once you are into this canvas and you are using the Simscape blocks, by default, you would need the solver configuration. So we connect this. Okay. Now we want to measure the voltage. So what we'll do is we'll bring the voltage sensor again, making the proper connection positive to positive and negative to negative. And then further, since we want to measure the voltage, I'll just put it over here. Okay, and I'll just name it as voltage. Okay, now few changes now we'll do in the model. So we'll double click again to the model. And what we'll do is we'll expose the state of charge port because we also want to measure the state of charge when we are discharging the battery. And at the same time, we'll also do one thing. We'll also model the thermal port. Okay, so as you can see over here, for the thermal port over here, so we say 34.47% parameter assumed. Okay, so it's an assumption based over here. So if you know the real value of the thermal mass, you can put it over here. Okay, so once we do these changes, exposing the state of charge and the thermal port, you'll see some changes over here in the port. So you can see that we have thermal port over here and the state of charge port over here to measure that. Now, what we'll do is, let's just imagine that uh, this battery is kept inside a insulator. I mean, this is just a vague assumption, just to kind of give you an overview of the thermal aspect in this physical modeling environment. Okay, so what we'll do, we'll just connect one insulator. Okay, so this is just an assumption. Okay, and further, we'll try to measure the temperature. So we'll have temperature sensor in place, and then we'll connect to one port. So these are what? These are the physical ports that you see, A and B. Okay, so you can just imagine that if I want to do T1 minus T2, okay, T1 is the temperature of the battery and T2 is fixed temperature. We'll just bring the thermal reference. Okay, so if you double click on this, what is this? It is basically a reference point in the thermal network where the temperature is equal to absolute zero. Okay, so basically we are doing T1 minus zero. So control R. Okay, and then further we want to measure the temperature. So again, what we'll do is we'll bring a PS to Simlink converter over here, and then I will connect it over here, and I will name it as temperature. And I'll also bring one more block over here, one more connection for the measurement of the state of charge. So I'll just connect it over here. I'll put it as SOC. Okay, so this is how you complete the model. This is a very simple model. I mean, nothing like, I'm not bringing conduction, convection. For example, a lot of questions like when we build this, like, do you have conduction, convection blocks? Yes, you can use that. For example, if you just want to measure the heat transfer due to convection, you can have this convection block. This convective heat transfer, make the proper connections, and you can just model the system. Now, once that is done, I'll just quickly just to visualize it. I will click over here and select the layout 3 and okay. Okay. So now once I run it, so you see over here that we have this voltage because we are discharging, then we have temperature, and then you have state of charge, how it is reducing. Okay. A very simple example, nothing crazy, but just to give an overview that how you can use this blocks which are available in Simscape and Simscape battery. Okay, now moving back, now the biggest question for the teams is that most of the cases when we are selecting which cell we are using, it may not be the same that we have in the Formula Student competition. So for that, let's get back. So the question basically is that how do we parameterize our cell model? Now, until now, what we saw is that there is one RC equivalent. Okay, so let's redefine the problem of parameterization. So the problem is that you have a cell, and you know that you have uh, what's the equivalent circuit equivalent cell model. Okay, now you want to parameterize. What are those values? You want to parameterize EM, you want to parameterize the R naught, you want to parameterize the RC equivalent, or you can say the time constant, or you can individually parameterize C1 and R1. Okay, so now to do that, there's a procedure. The procedure says that you have a cell, okay, and through some test, let's take HPPC test that you have performed, and you have for certain current input, you have basically charging and discharging, you have the voltage profile with you for a certain temperature, okay. And then what you do, you make this Simscape model, the one that I just showed you, and then you try to make sure that the voltage that you get from the test and that the voltage that the model is giving, they converge. And at the same time, what are we optimizing? We are optimizing these values. Okay. So we are optimizing EM, we are optimizing R naught. And the video that I'll show, it will basically, it will show you the time constant optimization, but both are like related. So basically, if you see tau is equal to C1 into R1. Okay. Now you do until when? Until you get the convergence. So once you do it, once you get the convergence done, then you have the parameters set, and those parameters you can use in those blocks. Now further, to show that, let's quickly go to the STO, that is a Simulink Design Optimization, okay, which is a tool. But before that, just I've been repeating this HPPC test. So I've just put a slide over here that what is this hybrid pulse power characterization test. So it is basically charging and discharging. Okay, so info is over. I'm not going to get into detail, but even if you just search on the internet, you will see that what this test is all about. So I think uh, based on my interaction with the different Formula Student teams, this is the one workflow that I'm seeing that a lot of teams are performing. They have the test done for their cell, and then before they get into the actual modeling, they want to make sure that all the cell parameters are properly parameterized. Okay, so now as we mentioned that we have the test data and we have the model in place. Now, when we use the Simulink Design Optimization, under that we have the parameter estimation. So this is what it does. So currently, before I start the video, so this is running the optimization. So over here, you can see that the blue curve, that is a voltage response for the current input, is the measured or the experimental data. And the orange one is the current simulated output. Now, when we run the optimization, you will see that slowly it starts converging and it gives you values for all those parameters. Okay, so let's get started. So, so this is the UI that you see for the Simulink Design Optimization. There might be some change because it has been updated in the recent releases, but the intent is same, basically that you have the measure data and you try to converge it with the output that you're getting in the model, and then you try to estimate the parameters. Okay. Okay, so now you can see that slowly it started converging. Okay, so it started until from here, something like this. And at the end, when I go over here, you can see it is nicely converged. Okay, so yeah. So once you have this, so these values can be saved in the workspace, and those values, what you can do is you can come back, and then in this model, okay, you can feed this over here in the state of charge, in the EM, and all those values. Now, one important aspect over here is that in the charge dynamics, when you go, when I built the model, it was no dynamics. I didn't consider the dynamics, but further you have options to sort of select how many time constant do you need. You need one, you need two, you need three. So for example, if I check three, you can see over here that it is asking for the R1 and R1 and then tau 1, that is the time constant. And similarly for R2 and tau 2, and all these similarly R3 and tau 3. So again, to look back in the documentation, what does that mean? So the RC pairs that we are selecting, for example, this is one example of two RC pairs. Okay, so you will see over here when you select two RC pairs. Okay, so basically two time constant dynamics. You see over here that is R1 and C1 and R2 and C2. Okay, so here what we are doing is we are finding those parameters using the similar design optimization or parameter estimation, and then you will feed those values in this block. So then once you have it, then you can see that, okay, this is actually replicating the model which is there in the in a formula student card. Okay, now further, once you have done regarding simulink design optimization, okay, so this we have seen, and then we have also parameterized it. Okay, so this is one example. I was just showing that when you open the block parameters, this is how you need to fill in all the data. Okay, so just give an example that we have parameterized for the final model that we are going to show. We have parameterized it with a cell, with a Molly cell of this configuration, and simple model and no dynamics. Okay. Now, further, once you have your cell built, okay, now the next target is to build a pack. Now, we have already, understood in the initial part that why pack is important. Okay, so for example, just take example of a formula student endurance run or any dynamic run. So you can have kind of like multiple a pack consisting of, for example, a few of the cells in series and few of the cells in parallel. So in that case, if your battery department want to study each of the cells in each of the pack, or they want to group certain of the cells, or they want to study the how, you should have the topology, or how you should have the module set, or how you should build the pack. And then you want to see, measure the voltage, measure the temperature, and how it is impacting when the vehicle is running through the endurance run or some other dynamic event. So this all for that, you need a battery pack. And there can be other applications as well. For example, the best example is you want to create a battery management system, because in that case, you will definitely want to measure the temperature either for each cell or for certain groups or for certain modules. Okay. So for that, there's an easy process. So in SimScape Battery, we have battery builder app. So what we do in battery builder app is that we start with the cell. So you go to MATLAB, and under the apps, you select for battery builder app. And then this is the app that opens up. And then it gives you, excuse me, it gives you the option for selecting what should the geometry of the cell. So for example, here we are selecting the cylindrical cell, and then you can define the cell properties, and you can parameterize it. Here also we have given that how do you want to parameterize the cell. Now, once the cell is done, you want to make a parallel assembly. Okay, so you start with the assembling it based on how do you want to stack it along x-axis or along y-axis, and number of rows, and what will be the topology. Okay. So now once you have created the parallel assembly, the next target is to create a module. Okay, that how you want to create a module. So once you click on the module tab, so it will give you option again, like first of all, you need to select the assembly, and then how of number of series assemblies you want to keep. So that also option is given. And at the same time, once we are modeling all these, you also get options for how do you want to model the system. Okay, whether you want to model it as a detailed model, or whether you want to group it, or you want to have a lump model. So we'll talk about more about that, but just give an example. So once the cell is set, parallel assembly is set, your model assembly is set, finally we go for a battery pack. And then once we have built a battery pack, now this battery pack, you can export it as a library, and that library that you get further, you can further use that block in your modeling aspect. Okay, so I'll show you how does it look like. So once we have created library, you can go over here. So it will show you that this is the battery pack that we created. Okay, so you can see over here. Yeah. Now, to just quickly give an example, how does it look like? A very simple battery pack that we have. So if I just open it, so this is how it looks like. This is how the battery pack looks like. Okay, depends on the configuration that your battery is. So if you go inside this, you can see over here that how the way we have made the modules, the way we have made the parallel assemblies, you will see over here. And then you can also parameterize all this battery pack. So once you are done, okay, then you can see that these all the things that you can measure. And once you are using the battery pack builder app, you also have the options for balancing. Okay, so passive cell balancing, the option is there. If you activate that, you will see this option over here. Okay, so in case if you want to build a balancing algorithm, you can use that and try to balance the cells. Yeah. Okay, so I hope, I mean, these things are almost clear to everyone. So further, another approach is that if you want to use the API, that is also there. I'm not covering that, but just give an example of that. Okay. So finally, like this is the one reference that we are taking, that this is how we have implemented a battery pack. Okay, and this is the one that I was talking about. You can use the SimScape battery API to start from build a battery pack, starting from cell to parallel assemblies, to module assemblies, to a pack. Okay. Now, one thing which we were talking about was the model fidelity for the pack. Now, getting into detail of that, so there could be multiple applications, like someone from your battery department, they want to build a BMS system, and their whole focus is on each of the cells. So you can have the options for a detailed modeling of your battery pack. Okay, where you can see the thermal equivalent and electrical equivalent to these. Or your aim is just to have a battery pack aluminum system where you don't care a lot about like each of the cells. You just want to uh, test this battery, measure the voltage, measure the temperature as a lump, and you just want to club it to maybe like a powertrain model, and just want to measure the state of charge. Another aspect is that you want to group it. I mean, rather than going for a detailed model, which can be computationally expensive, you want to go for a grouped model. So in that case as well, you can group it, and you can just give an example that you can impose a fault in one group, and then you can measure the vehicle performance. Okay. So again, for our application, what we have done is we have selected the group model resolution by dividing each module in 4 cells. Okay, this is how we have grouped it. Okay, now again, if you start getting into detailed model for each cell, it will be very slow because it is computationally expensive. So you need to find that trade-off. Okay. Now further, one of the another aspect for a lot of teams is the thermal aspect. Okay, so there could be like different kind of heat transfer, and based on that, you want to measure the uh, temperature. There could be different modes of heat transfer like convection, conduction. And this is one example, like if you want to uh, measure the impact of heat transfer between the cell from the pack to the ambient environment or the environment. So that also you can model. So just to understand, for example, this is the thermal equal model. And again, this option you can select it in the API or you can select in the battery pack builder app. Now, how do you do it? Just to give you an example, you have a thermal mass and you just have a convective heat transfer block over here. So when you model it, when you select that in the app, in the battery pack builder app, or if you include that using the API, and when you have the pack, once you go inside that, you'll be able to see that how it has been modeled. Okay. Further, another aspect for the mode of heat transfer is between the pack and the cooling plate. So again, it can be conduction. So again, that can be modeled using the blocks which are there or the options which are already there in the SimScape battery pack builder app or in the API. So these are two modes of heat transfer. Another could be, so this is what the block is showing, that once you do that, once you activate those options, it will ask for the different coefficient values. Okay. Now, further, another interest for the teams is within the pack, if we can do that or not. Yes. If you want to measure or you want to analyze the heat transfer between the cells or intercell path, that also can be done. Okay. Similarly, if you want to have intercell radiative path, so that also can be activated. What happens is once you activate that, so it will ask for the respective values over here. Now, one question which we often get is kind of how to find these values. Because if you see, like if you start modeling it, and especially the thermal part, and you add intercell path, and you have also the heat transfer between the uh, pack and the plate, between the pack and the ambient and the environment. So you'll have bunch of heat transfer coefficients, thermal conductivity values that you will need to provide. So in that case, one, I think I would say I would call it as useful tip, maybe useful tip, but what we have learned from teams is that the best way to find is that if you're performing CFD simulations, thermal analysis in the different softwares, from there you can extract those values and you can feed it over here. So that's what we have seen the teams who are using SimScape battery. That's how they have found the values and they have implemented over here. So just to summarize, so we have, for our purpose, for our application, we have selected part 2 ambient and part 2 cooling plate and intercell path. All these are implemented in the model. Okay. Now, next aspect, which is not that much maybe useful for the teams, could be for including cooling plate, but just to give an overview that you can choose a cooling plate topology. So we have different blocks over here, like edge cooling, parallel channels, U-shaped channels, and you should keep on checking the latest release notes because we are adding more and more blocks to the SimScape battery. So you can use that, and I'll show you that how in one of the examples you have utilized this for the cooling in the cooling plate. Okay. Now, once you have implemented the cooling plate, okay, in that also you have the options. How do you select the fidelity of the modeling aspect? So again, it can be, the cooling plate can be imagined or assumed as one lumped model. Okay, or you can discretize this based on the axis that you want to select, whether it is along x-axis or along y-axis, or you can also discretize this at the same time along x and the y-axis. Okay, so once you do all this, based on that, those options will be available in your block. Okay, for our current purpose, what we have done is the plate was discretized in a 4x4 layout as shown below. Okay, now just a last topic that we wanted to cover is the importance of, I mean, how to, if you want to build some kind of BMS systems. Okay, so SimScape gives you multiple blocks which you can easily use in your battery pack. For example, you have battery CC and CV, constant current and constant voltage charging, and then you have passive cell balancing blocks, and you have multiple estimators. I think this is one of the important blocks that teams or the algorithms that teams work on, because they want to measure the state of charge, or further also want to measure the state of health. Okay, so and then you have thermal management. For that you have battery cooling control. But I'll just open the 24B version over here, and then I'll quickly open the library, and I'll show you that when you go to Simscape into battery, you have BMS over here, and here you can see that for cell balancing, we have provided a block for cell balancing. For current management, we have battery CCV, battery charging current limit, and battery discharging current limit. And then we have multiple number of estimators over here. I think the one of the favorite for the teams which I've seen is that the Kalman filter. Because it takes into the dynamic effect. Okay, and otherwise, I've also seen I've also seen teams building their own custom estimators over here. But yeah, I mean, you have plenty of these. You can just use any of the blocks. Okay, and further, if you go to thermal management system, so currently we have battery coolant control and battery heater control blocks, which can be used. Now, to give an example of how we are using this, so over here, let's talk about the battery management algorithms for charge and discharge. Okay, so yes, charging and discharging. So we know that how to build this battery block, battery pack that we have already seen. And I just showed that what are the different blocks which are available for the CC and CV block. Okay, so this is a block that we are using. And further, when we simulate it, so what we are doing is we have marked the start state of charge, which is below minus 100. And then we have a maximum state of charge. So currently it is charging. Okay, and at certain instant, we have put a logic over here that at what instant it should discharge. Okay, so you can see over here that it starts discharging. Okay, and you can see and you can measure the state of charge, as well as you can measure the current as well. Now further, building on top of this model, what we did was that let's kind of cool the battery. Okay, so for that, we are using the battery coolant control. So what we are doing is we have set a coolant on upper limit, and then until certain time, okay, we are increasing, the temperature is increasing, and when we put the coolant on, we'll see that how the temperature is decreasing. So the whole point over here is that using these blocks, you can easily analyze your battery systems. And further, if you want to include it with a vehicle model, that also you can do it. Now, one last example is this one. Again, we have this battery pack. And what we are trying to do is we are trying to estimate the state of charge of different assemblies. So we have 1, 2, and 3 assemblies. And these are the real values of your state of charge for these assemblies. And using the state of charge estimator, which is a Kalman filter based, we'll see that we are able to track it as close as possible. Okay. So you can see over here that when we use this block, the results that we're getting is quite convincing, because it is able to take into account the charging and discharging effect, and able to track the real state of charge. Okay. Now, just to summarize what we did today, or what we just saw today, where we started with a cell, we built a battery pack, we built further, we implemented a cooling plate, and further we also saw that how you can implement different BMS blocks to whether charge and discharge, or you want to build a coolant control, or if you want to estimate the state of charge. Okay. Now, to learn all this, there are multiple number of resources. Okay, you just visit all these pages. You have a Simscape battery dedicated page. We also have now Simscape battery on-ramp that you can, that's a self-paced training that you can also do. Okay, and there are other resources as well over here. Okay, we'll also try to put that in the comment section of the YouTube. Okay, and if anyone is interested in the slides, we can send that. Now, before I just close this session and take the questions, just wanted to share with all the Formula Bharat teams that this year we have one exciting Formula Bharat MathWorks KitPad simulation challenge in which there are a number of tasks, and one of the tasks is to build a battery model and estimate the state of charge. So this session or the resources that we have shared that can be useful to kind of participate in this challenge, and there are cash prizes. There is more information. You can visit the Formula Bharat webpage. All the information and the documentation is present over here. That how we are, how you can get the scores and what are the criteria for judging. All those information are over there on the Formula Bharat webpage. Okay, and then further, just to again remind that we have a student competition tutorials videos page where you have multiple videos on vehicle systems which are relevant to the Formula Student competitions. And then we have also launched this MATLAB student channel where we are adding more and more resources. If you want to follow, you can have a look. You can follow, and we'll be like every week we add some tips. We add some also stories and posts which can help you kind of learn more. So with this, I'll just share the contact details. So if you have any queries regarding this, or if you want to uh, have some resources, or you want the slides, this all just reach out to me at racinglaunch@mathworks.com, and I'm happy to share the slides with you. Yeah, thank you. I think I am right on time. Yes. Okay. So yeah, I mean, we have got some time. So if you have any questions, you can put that in the chat, and then the organizers will let me know in the chat over here that what are the questions. Yeah. Yeah, feel free to ask questions if you have any questions. I'll try my best to answer those. And if not, I mean, I can get back to, or you can reach out to me at racinglaunch@mathworks.com. So organizers, are there any questions on the YouTube chat? Can let me know. Okay. Okay. So yeah, just let's wait for 1 more minute, and then can close it off. Yeah, in any case, like if you don't have any questions now, you can again watch the video, or even if you look for some resources, you just type MATLAB, Simulink, or Simscape battery, you'll get enough resources on the internet, and you can just follow those. But if you have some specific questions around anything, just reach out to me at racinglaunch@mathworks.com. Okay, so I'll stop here, and Perfect. Okay, so yeah, again, once again, thanks to the Formula Bharat team for organizing this live session, and looking forward to another such sessions in future. Thank you.
Thank you so much, Veer, for doing this with us.
Yeah, no problem. Yeah, thanks. Yeah. Yeah, so I'll leave the meeting now. Fine.